Hello and welcome to lesson number 3 here at Reignite Hope. Today we're going to talk about a couple of important topics. We're going to talk a little bit about flux core welding, and we're going to talk a little bit about welding certification. It also has a couple other things listed on your lesson plan there about MIG setup, but we're going to talk about that more back in the shop than we will here in the classroom. But you might remember back when we were talking a little bit about stick welding, we had a stick electrode here with this flux coating on the outside of the steel electrode, and that flux would burn and create that smoky cloud around our arc, which would shield it from the air. Well, today we're going to talk about this same kind of flux being inside of our flux core wire. Flux core welding and MIG welding are two processes that we would also call wire feed welding. You might remember, if you've been back there in the shop and done MIG, here's a spool of MIG wire. It looks copper colored, so this is for welding steel, and this is a solid wire. There's no flux inside of this, because with MIG we use gas to surround the arc. We use an argon CO2 mixture of gas to surround the arc and shield it from air. Flux core wire looks a little different. It looks silvery colored here, and you can see right away when you picked up the torch and looked at it, if you saw this color wire coming out of the torch, you would know that the machine is set up for flux core. Now, most machines will do both. They'll do flux core welding or they'll do MIG welding. You need to put the right wire inside of it, though, for what you're trying to do. So let's start off here and talk a little bit about flux core. So it's abbreviated FCAW, flux core arc welding. It'll often have a designation on the end of it, either an S or a G. If it has an S, that means that it's self-shielded. That means that it just has this flux actually inside the wire, actually in the middle of the wire. You can't see it, but it's in there. Uses no gas, just the flux core. So that's why we would call it a self-shielded process. And the polarity we want, here's our friend polarity again, needs to be DC negative. We want our torch to be negatively charged instead of positively charged. Now, flux core with a G at the end of it would be gas shielding. So then we use gas like MIG does, and we've got the flux still inside the wire, so it's actually a dual shield process, but we need DC positive this time, our torch positively charged. So two types of flux core welding, self-shield and dual shield. Dual shield if it's using both gas and flux, self-shield if it's just using the flux all by itself. The wire diameter can vary, just like with MIG welding. It might be as small as, say, 35 thousandths, might be up even over 100 thousandths. The thicker the wire would mean you're welding thicker metal and turning the machine up hotter. Now, with our gas, going back to the dual shield process here, just like with MIG, we could use 75% argon and 25% CO2, and that's what we use back here in the shop most of the time. You also could use 100% CO2 if you would like as well. Either one of those mixtures would work for flux core. Flux core is a very popular process in both construction and in manufacturing. Particularly outside, you can use the self-shielded flux core really well. It's pretty tolerant to breezes and things like that out in the outdoors. Inside, where you're using the gas and the flux, is where you're mostly going to be away from the wind, not blowing your shielding gas away. So that would be a lot of indoor welding, maybe with the dual shield. But again, both are very popular, very employable types of welding. And again, it's a wire feed process, and again, most machines that will do MIG will also do flux core. Not all machines will allow you to add the gas, so if you're going to buy a machine, make sure it's got a gas port on the back if you want to do dual shield flux core welding. Okay, now let's talk a little bit about welding certification. We've often heard the term somebody being a certified welder. What does that mean? Well, when you hear that somebody's a certified welder, that just means that they passed some test in the certification process to become certified, but it doesn't tell you any more than that. You need to ask some more questions there. Welding certification is very specific. There are different certifying bodies in the world. The American Welding Society is the largest certifying body in the world when it comes to welding, often abbreviated AWS, American Welding Society. But other bodies have their own certifying as well. The American Petroleum Institute, for example, does certifications. LA City even has a certification if you're going to be doing any kind of structural steel welding within the city of Los Angeles. You need an LA City cert. But the AWS certification, which is what we will be getting you here, that's used all over the world. But it's very specific, like all of them are. So when you get certified as a welder, you get certified in a particular process. So you could be certified in MIG welding, but that doesn't certify you to stick weld. That doesn't certify you to flux core weld. That doesn't certify you to TIG weld. If you get stick certified, that doesn't certify you for anything else either. So it's certification by process. Also, it's by metal. So you might be certified to weld steel in a particular process. You might be certified to weld aluminum in a particular process, but getting certified in one doesn't certify you in the other. It gets even more detailed. The position in which you got tested. You might have got tested welding in the vertical position uphill, which is great. And when you're certified uphill, that means you will also automatically be certified for flat and horizontal, but it still doesn't certify you for overhead. And when you get certified for overhead, it doesn't certify you for vertical. So you get certified by position. You even get certified not only again by the type of metal, but even the thickness of the metal. So you might get certified to weld within from an eighth of an inch to 3/4 of an inch, but you're not certified beyond 3/4 of an inch. So just all depends on the test that you're taking, what you need to get certified for. All that to say, gosh, you could end up spending the rest of your life getting all the certifications, but nobody needs all that. In many cases, all you're ever going to need is one certification. Big Jim here, who's part of our team at Reignite Hope, was a welder with the union for 40 years, and he had one certification, but that's all he needed. It was a stick certification for doing pipe, and he never needed TIG, he never needed MIG, he never needed flux core, he never needed any other metals or any of that. That's all that he needed. So during our process here, most of you are probably going to get 2 certifications, each in a different process. So those of you that are on the manufacturing track are probably going to get a MIG certification and a TIG certification. Those of you on the construction track are probably going to get a stick welding certification and a flux core certification. That's 2 certifications. That's a really big deal. Even being certified in anything is a big deal because a lot of welders aren't certified. But bless their hearts, somehow they're out there and they got a job. But a lot of companies require certification, particularly big companies. And so being certified will give you a distinct advantage in getting employed as a welder out there. So don't get all caught up in wanting to get 8 or 10 or 12 certs. Nobody needs a pocket full of certs to get hired. If you've got 1 or 2 certifications, that'll be plenty to get your first welding job. Sometimes even the companies that hire you will certify from within. So they'll interview you if they like your personality. They'll have you run a bead for them. They like your bead, then they'll hire you, and then they'll have you weld something as an employee, and then they'll send it out to be tested, and you'll get certified within their company. Now, a lot of times that certification is only for their company. You go now and work for another company, that certification may not be recognized at all, whereas the great thing about the AWS certification, that's recognized just about everywhere that you might go. You might need something additional, again, if you were going to the American Petroleum and working in the oil refineries or something like that, or the structural cert for LA City, but again, in most cases, your AWS certification is going to be really all you need to open the door. So we'll talk more about that in the days and weeks ahead and get you ready for those 2 certifications coming up here sometime in the middle of December, and it's going to be super exciting to see that you're all going to leave here as certified welders by the most prestigious certifying body in the world, the American Welding Society. Okay, how about let's go over what quiz number 3 is going to be. So this coming week you're going to take quiz number 2, but we have already talked about this, but you're going to end up getting quizzed on it the week following that. Quiz number 3. List the 5 common joint types. So we talked about those. Let me grab a couple pieces of metal again here. We had 2 pieces of metal we're going to weld together, and we talked about how we could put these 2 together in 5 different patterns, if you will. One, we can just butt them together, and that would be considered a butt joint, B-U-T-T, a butt joint. We could put them like this and form a T-joint. We could just lay them like this, overlapping, and that's going to be our lap joint, where we'd weld here or weld here. We could also make a corner out of our 2 pieces, and that would be a corner joint. And then lastly, we could put the 2 pieces together like this and form an edge, and we'd weld the edge. This would be an edge joint. So those are the 5 types of joints: butt weld, lap weld, T-joint, corner joint, and edge joint. Now, we could also take those 5 joint types, and question number 2 says, list the 4 joint positions. So for every one of those 5 joint types, we could put it in 4 different positions. So I could take my lap joint here, lay it in this position, and I could weld like this, and that would be the flat position, also designated a number 1, a flat position. We could put it like this, and now I'd be welding it in the horizontal position, and that would be designated as a 2, position 2. Put it like this, and now I'm welding vertical, either vertical up or vertical down, but either way vertical, and that would be designated as position number 3. And then finally I could put it up here and weld it overhead, and that would be considered position number 4. So our 4 joint positions, now different than types, positions are flat, horizontal, vertical, and overhead. And so any one of the 5 joint types, butt, T, lap, corner, and edge, any one of those 5 can be put in any one of the 4 positions to be welded. That's question number 2. List the 4 joint positions. Then what does MIG stand for? M-I-G, MIG, stands for metal inert gas. The metal is our metal electrode, and our metal electrode is what carries the electricity. We just talked about the wire feed process there with flux core. So this is metal inert gas. Again, the metal is our wire that's being fed into the weld, carrying the electricity. Same thing with the flux core. The inert gas is our mixture of argon and CO2. The inert gas is the argon. Inert means it won't react with anything. It doesn't combine with other elements. It won't burn. It won't do anything, but it does shield for us. That's what it does. And so we use usually a mixture of argon and CO2 for our MIG welding process. Now that's sort of the slang term, is MIG welding. The technical term is GMAW, which is gas, metal, arc welding. And again, gas is our shielding that we're using, argon and CO2. Metal, again, is our wire, and then it's an arc welding process. That's the technical term for it, is GMAW, and that's question number 4. What does GMAW stand for? So once again, list the 5 common joint types, list the 4 joint positions, what does MIG stand for, and what does GMAW stand for. On top of that, we'll have our normal 3 tape measure questions for you as well.